All right, let's dive in. We're talking about something the source material calls the silver bomb. And yeah, it's a pretty explosive idea. It's about a potential revolution in battery technology that could literally reshape our energy future. But it all kicks off with this fascinating collision between two completely different worlds.
And this quote, this really gets to the heart of it all. The banks are playing a paper game. Samsung is playing a physics game. Physics always wins. I mean, wow, it perfectly sets up this epic clash, right? You've got the financial markets playing the paper games, and then you have the hard reality of a technological breakthrough. The core argument here? Physics doesn't care about paper, and a major collision is on the horizon.
Okay, so how did this whole thing even start? Well, it all begins with this really weird paradox. It's a moment where the market is screaming one thing, but in a lab, halfway across the globe, a massive technological secret is quietly being revealed.
Get this, on one particular Friday, two huge things happened. In the market, the paper price of silver was getting absolutely smashed. But at the exact same time, in a lab, Samsung was quietly confirming a new production line for a groundbreaking solid-state battery. And guess what's at the heart of that battery? Yep, silver. It's this total disconnect, this complete contradiction that really kicks off our story.
Now, to really understand why this is such a big deal, we have to look at the fatal flaw in the lithium-ion batteries we've all been using for decades.
The big problem here is something called dendrites. Okay, so what are they? Basically, when you charge a battery, especially when you're fast charging it, these tiny needle-like crystals of lithium can start to form. They're like little roots growing inside the battery. These things are the reason your phone battery just doesn't hold a charge like it used to, and in the absolute worst-case scenario, they're the reason you hear about electric vehicle batteries catching on fire.
And the whole process is just destructive. First, these little crystals form. Then they grow, kind of like weeds. Eventually, they get long enough to actually pierce the internal wall that separates the two sides of the battery. And when that happens, boom, you get a short circuit. That leads to what's called thermal runaway, which is just a fancy way of saying the battery gets super hot, super fast, and can burst into flames. Honestly, this one single problem has been the biggest roadblock to making batteries that are safer and can charge way faster. So for years, the absolute holy grail for battery researchers has been to create a solid-state battery, one that finally solves this whole dendrite nightmare. And, well, according to the research coming out of Samsung's labs, it looks like they've actually done it. They've found the solution.
And the secret ingredient? The magic bullet that stops those nasty dendrites right in their tracks? It's silver. You heard that right. Samsung's big breakthrough is this super thin layer of a silver carbon nanocomposite material they put on the anode. And look, this isn't just some crazy theory. This is published science that's already heading towards mass production. So how in the world does this actually work? Well, think of that silver carbon layer as a kind of traffic controller at the nano level. It creates this perfectly smooth, stable surface. The silver particles basically guide the lithium ions, making sure they deposit nice and evenly across the whole surface, instead of clumping up into those dangerous, sharp spikes. And the result is game-changing. You get a battery you can charge incredibly fast without worrying about fires. It's also smaller, lighter, and way more powerful. The key takeaway here is this. Silver isn't just a little sprinkle of something extra. It's the absolute core technology that makes the whole thing work. Okay, so that's the cool science part. But what happens when you take this breakthrough out of the lab and put it into millions and millions of cars? Well, this is where things get really interesting. We're about to shift gears from chemistry to economics and straight into what the source calls a massive, coming demand shock for silver. Okay, to really get the scale of this, let's look at the numbers. Let's start with a regular gas-powered car. Right now, it has about 15 to 20 grams of silver in it.
Now, let's jump to a current EV. That number already goes up to somewhere between 30 and 50 grams.
But here's the kicker. With these new solid-state batteries, we're talking about a huge leap. Conservative estimates are saying you'll need at least 100 grams of silver per car, and that's just for a car. Trucks could need a whole lot more. So, let's be clear. This is not some tiny, gradual increase. We are literally looking at doubling the amount of silver needed compared to today's EVs and a whopping 5 times increase from a gas car. Now, just try to imagine what that means when you start producing millions of these new vehicles every single year.
And this leads to a conclusion from the analysis that is, well, it's absolutely staggering. If this one technology gets widely adopted just for cars, it could gobble up 25 to 35% of the entire planet's annual silver mine supply. Just think about that. That leaves precious little for everything else that needs silver, like solar panels, all our electronics, you name it.
And this brings us right back to that central conflict we talked about at the beginning. You've got this insane vertical spike in demand that's on a collision course with a global supply chain that is frankly already stretched to its breaking point.
You see, the silver market is already a tight squeeze. Industrial demand for things like solar panels, electronics, all that stuff already eats up almost half of all the silver we produce. There's just not a lot of extra floating around, and that's before this gigantic new demand from the battery sector even shows up to the party.
The analysis even has a name for this, the extinction equation. And it's pretty simple, really. You take all the current demand for silver, and then you add this massive new demand from solid-state EVs on top of it. The result? Total demand could easily blow past the entire world's annual supply. That creates what's called a structural deficit, which basically means there physically isn't enough silver to go around. Period.
So you might be thinking, well, can't we just recycle more? Great question. But according to this analysis, when it comes to silver, that's pretty much a myth. See, gold is easy to recycle because it's usually in concentrated forms, like jewelry. But silver, it's often used in tiny, scattered amounts in electronics and other products. The research calls it vampire dust. It's just not worth the cost to try and recover it all, which explains why less than 20% of silver ever gets recycled.
Okay, so if recycling won't work, what about just mining more? Well, that's not a quick fix either, not by a long shot. For one, it can take 10 to 15 years to get a new mine up and running. On top of that, the quality of silver ore around the world has been dropping for years. That means miners have to dig up way more rock just to get the same amount of silver. The bottom line is, the supply side just can't react quickly to a sudden shock in demand like this.
So you've got demand about to go through the roof and supply that's basically stuck in place. What's the end game here? Well, the analysis suggests this whole situation could completely change how we think about silver, how industry and even governments view this metal.
The argument is that the demand for silver in batteries is about to become inelastic. That's the economic term for it. Think about it. Car companies can't just use less silver to save money because that brings back the risk of their cars catching on fire. It's a non-starter. So they'll have to buy it at pretty much any price. It stops being an option and becomes an absolute requirement for safety and performance. And this is where it gets into a really fascinating potential scenario. Right now, governments all over the world are mandating a switch to EVs. But what happens if their car companies can't get enough silver to build safe batteries? Suddenly, those national mandates, those big political promises, are at risk of failing. And that could force governments to do something drastic, like declaring silver a strategic material, stepping into the market to secure the supply just for their industries.
So, we're left with this one massive question. If this battery technology really is the future, and if this supply and demand crunch happens the way the analysis suggests, could silver stop being just a precious metal and become a critical strategic commodity? I'm talking as vital to this century as oil was to the last one. It's a pretty powerful thought, isn't it?